This work is titled Observing Vorticella Feeding Currents with Digital Inline Holography Particle Tracking. Vorticella are microscopic organisms that clean toxins. They form a critical part of aquatic ecosystems. Our goal is to understand their 3D feeding currents. We built a digital inline holography setup to record the organism's interaction with beads in water. We use compressive holography to reconstruct the beads and apply particle tracking software to extract bead paths over time. The key technique here is compressive holography. In regular holograms, there are millions of non-zero points, as shown in the left and zoomed in the middle frame. In contrast, compressive holography produces a sparse volume with few points, as circled in red on the right. This sparsity makes particle tracking possible. We also add a processing step to remove spurious and out-of-focus points, as circled in the compressive volume on the left. The process volumes contain only real focus points in the end. We input these final volumes to particle tracking software to get our results. We reconstruct feeding currents showing the path of each bead over time, moving left to right. In 2D, beads that are far from the organism float along unaffected. Closer beads, such as the orange and blue paths at the bottom, show interaction with the organism. In 3 dimensions, we see similar behavior, along with particle motion along depth. These behaviors need to still be further investigated. We presented a system that can successfully track particles around a Vorticella, providing a first step in understanding this organism's behavior. We input real noisy data as shown on the left, and extracted feeding currents in 2D and 3D.